In a certain chemical experiment, the volume of gas produced at 0 degrees Celsius is 6 litres. The volume increases by 1 litre for every 5 degrees rise in temperature. So what is the independent variable? What is the dependent variable? And give a reason. Find the slope of this line and express it as a rate of change. Sketch a graph showing the independent variable on the horizontal axis. Write down the equation of the line and write the volume of gas produced as a function of the temperature. Find the temperature at which the volume of gas is 10 litres. So part 1, what is the independent variable? What is the dependent variable? Give a reason. So as the volume produced depends on the temperature and not the other way around, the independent variable is the temperature and the dependent variable is the volume of gas produced. So the volume produced depends on the temperature. The temperature does not depend on the volume. So the volume produced depends on the temperature. So the independent variable is the temperature. That's not dependent on anything. And the dependent variable is the volume of gas produced. So the volume of gas depends on the temperature. So the volume of gas is the dependent variable. So the volume of gas produced depends on the temperature. So the higher the temperature, the more gas is produced. The higher the volume of gas is produced. So the volume of gas is dependent on the temperature. The temperature is not dependent on the volume of gas. Part 2, find the slope of the line and express it as a rate of change. So as the volume increases by 1 litre for each 5 degrees rise in temperature, the rise is equal to 1 and the run is equal to 5. And we know that slope is rise over run. So the rise is 1 because the volume increases by 1 litre, and the run is 5 because there is a 5 degree rise in temperature for every 1 litre. So the rise is 1 and the run is 5, and slope is equal to rise over run, because you get 1 over 5 is the slope, and m is the letter that is used to represent slope. So it's equivalent to doing the formula y2 minus y1 divided by x2 minus x1 if we had coordinates to use. And this formula is found in our formula tables. But in this question we're going to use rise over run. So 1 divided by 5 is a fifth. So the slope is 1 over 5, or a fifth. Thus, the rate of change of the volume is a fifth of a litre per 1 degree rise in temperature. So the rate of change of the volume is a fifth of a litre per 1 degree rise in temperature. Part 3. Sketch a graph showing the independent variable on the horizontal axis. So this being the horizontal axis. So the temperature has to go along the horizontal axis. And obviously then the volume will go along the y-axis. So we start off by drawing out our x and y axis. And there's no rule as such as to how far we go up on our x and y axis. But I'm drawing out our x-axis in steps of 5. So 5, 10, 15, 20, 25, 30. And our y-axis in steps of 2. So 2, 4, 6, 8, 10, 12. We're told that the volume of gas produced at 0 degrees Celsius is 6 litres. So we have to go to 0, 6 and plot our first point. And there's no rule about how far up we have to go on the y-axis, but since we're starting off at 6, we'd want to go up to at least around 12, which is twice that. But we could go up as far as 15 or 20 if we wanted to. There's no rule as such, but you definitely want to go up at least as far as 12. So if we want to draw on our graph and we know what the slope is, so the slope is 1 over 5, then we can just do rise over run and generate some more coordinates. So if I just zoom in on this, so if we imagine that we just have this starting point here of 0, 6, imagine that's all we had at the moment. So we have a slope of 1 over 5, which means a rise of 1 and a run of 5. So we'd have to do 5 steps across and 1 step up. So from 0 to 5 is obviously 5 across, so 5 across, and then 1 up. We're going from 6 to 7. And we would plot another point. Then we could repeat that again. 5 across, so we'd end up at 10 now. And 1 up, so we'd end up at 8. So 5 across and 1 up, and plot another point. And we can go again. 5 across and 1 up, and plot another point. And 5 across and 1 up, plot another point. And then what you could do is just join your points together. And they form a straight line or linear graph. So we have a run of 5 and a rise of 1. So the linear graph starts at 6 on the vertical axis, which is here, and has a slope of 1 over 5. This is shown below. So this was our starting point, 0, 6. We went 5 across, 1 up, 5 across, 1 up, 5 across, 1 up, 5 across, 1 up. And then when we had a few points plotted, we just joined them together with a straight line. And there we have our graph. Make sure that you label the x-axis as temperature in degrees Celsius and the y-axis as volume in litres. Part 4. Write down the equation of the line and write the volume of gas produced as a function of the temperature. So if we let x degrees be the temperature and y litres be the volume of gas produced, then using y equals mx plus c, the equation of a straight line, with m is equal to a fifth, so m being the slope, and c as the y-intercept, so c equals 6, the y-intercept, then the equation of the line is y equals a fifth x plus 6. So x degrees is the temperature, y litres is the volume. We're using the formula y equals mx plus c, so this is the equation of a straight line. It's found in our formula tables, where the m represents the slope and the c represents the y-intercept, the point at which the graph crosses the y-axis. We already found the slope to be a fifth, so we swap that m for a fifth, so it's a fifth x. And we know that the first point in our graph that we plotted was 0, 6. So the point 0, 6 is at 6 on the y-axis. So our graph crosses the y-axis at 6. So that plus c becomes plus 6. So the equation of our line is y equals a fifth x plus 6. So if f is the function which maps the temperature x degrees to its image, the volume produced in litres, so its image being its y values, then f of x maps to a fifth x plus 6. So just written as a function, all we have to do is swap the y for f of x and the equals for an arrow. Part 5, find the temperature at which the volume of the gas is 10 litres. So we already said up here that x represented temperature and y represented the volume of the gas. So if we're interested when the volume of the gas is 10 litres, then we're interested in when y is equal to 10. So we substitute y is equal to 10 into our equation that we created. So we swap that y for a 10. So get 10 equals a fifth x plus 6. We multiply across by 5 to get rid of the fifth. So 10 multiplied by 5 is 50. A fifth x multiplied by 5 just gives us x. And 6 multiplied by 5 gives us 30. So then 50 equals x plus 30. So 50 minus 30 will give us x. And 50 minus 30 is 20. Thus, the temperature is 20 degrees when the volume is 10 litres. So we are asked to find the temperature when the volume of gas is 10 litres, and the temperature is 20 degrees when the volume is 10 litres.